One of the principal subjects or topics we discuss in engineering is thermodynamics. The first law of thermodynamics is the conservation of energy principle. It simply means that energy cannot be created nor destroyed. It can only be transformed from one form to another. An example of this is the steam engine. We're harnessing the energy of the evaporated steam to turn a turbine, which then is producing electricity. There are other examples, but it relates to the internal energy of a system to the amount of heat added to the system and the amount of work done by the system. So basically, the first law of thermodynamics takes the principle of the conservation of energy and modifies it for thermal aerodynamic systems. Okay, so that's the first law of thermodynamics. The second law of thermodynamics is to do with a topic called entropy. And entropy, in simple words, means chaos or disorder. The entropy of a closed system is always increasing, and that is what the second law states. The entropy of a closed system is always increasing. What is the significance of this second law of thermodynamics? The more entropy we generate, the less energy is left to do useful work. Statistically, it's a puzzle, and it states a spontaneous process generates entropy, and it involves heat moving from a hot body to a colder body. In another way to describe the second law of thermodynamics is that when you open your window in your room, the hot air moves from the hot side, if it is hotter outside, into your cooler room inside your room. If the weather is nice and it's cold outside, and whereas your internal temperature is hotter in the room, then the hot air of the room escapes the window to the outside and forms an equilibrium. And that is the second law of thermodynamics. The third law of thermodynamics defines what the absolute zero temperature is, and it ties together the concept of entropy and temperature. And you can state this in the statement that the entropy of a perfect crystal approaches zero at a temperature of absolute zero. We also know this theorem as the heat theorem. Now, the three laws of thermodynamics were developed first. There is a fourth law of thermodynamics, and we have termed it the zeroth law of thermodynamics. And it relates to the concept of thermal equilibrium. Mathematically speaking, if A equals C and B equals C, then it just says that then A equals B. Basically thermal equilibrium. The temperature is a measurable and universal property of matter. That's what the zeroth law of thermodynamics states. There are two scales of temperature, and one is the Celsius and one is the Kelvin. And absolute zero is negative 273.15 Kelvin, whereas on the Celsius scale, zero is not the absolute zero. And you can put examples of this are the fact that properties of matter change with temperature. For example, conductivity of copper changes with temperatures. So basically, the zeroth law of thermodynamics lets us quantify the effects of other three laws.